good morning or good afternoon, ladies and gentlemen. And I have to apologize with my German colleagues, but unfortunately I don't speak German, so I'll try to use my best English, and I hope that you will follow what I want to say. We have a joke in Italy that says, be careful when giving the microphone to a university professor, because he will speak at least for 30 minutes. But I will try to speak considerably shorter than 30 minutes, so I don't want to waste too much of your time. So when I was invited by Salchev and Overraid to close this day, I thought about my experience as a professor as well as a consultant in the railway field that I have gained in the past decades, consulting for metros, railways and tramway systems. And so I thought about potential or possible applications of the system on the basis of the daily experience that we live every day on our tracks and on our lines. So I imagined some applications that that come up to my mind in a very short time, because I was not involved in the development of this project. So I thank again Salche for inviting me a couple of weeks ago to give this final speech. So I hope I can give some overview of what I think could be some useful potential applications of the system. Let's start from old and low traffic lines. When they are old, it means that sometimes they have to be renewed. And track renewal may be need to track deterioration, subgrade deterioration, any type of problem that may require a full track renewal. In this case, track renewal costs may be relevant, and this means that it is a large investment changing a full track in a given place or for a long time. I found this photograph on the internet, so it's not my photograph, but this looks a quite new train that has nevertheless some interesting and evident aligned track quality defects. That means that even if we renew a track, it may exhibit some undesired geometrical features after a short time. In this case, maybe the fast system appears to be an interesting alternative, because as we have seen from the tests from the Munich University, it looks very heavy and stable. And this means that whenever we have to renew an old track, maybe it could be interesting to evaluate the possibility of using the fast system, that it's a sort of fit and forget. That means that once a track is laid down, there is no need to make any of a conventional track maintenance like tamping, profiling, and ballast rehabilitation, and so on. There is no need for track stabilization, so of course the track can be reopened, the line can be reopened at a full speed after the concrete has got its properties. The second application is about underground railway links that are not so common, but we have some in Italy, and possibly in your home countries you can imagine some applications of typical underground lines that passes below the cities as links, as the name says. And they were traditionally built maybe 60 years or 80 years ago, 100 years ago, built on ballasted track. The picture you see here comes from the what we call passante, because it's a passing line below Naples that goes from the east side of the city to the west side of the city. It is a conventional line that was used, and it is still used today to let freight trains pass during the night. Temporary line closure is not feasible, maybe just for some night shifts, but it is not, let's say, a complete closure of the line for several months, as we can do for regional lines or for secondary lines, is not possible in this case. So a fast system is something that may fix the problem arising from high tonnage. That means many trains of low axle load or few trains with high axle load. We know that track defects accumulate a long time. And in this case, the fast system looks a quite interesting alternative, always with the aim of reducing or virtually eliminating the need of further track maintenance operations after the fast system track has been laid down. Another application comes from metros. Many countries have metros built in the 18th century and many more in the early 19th century, where we had a flourishing of metro systems around the world. And all of them, most of them, not to say all of them, are built with ballasted track. We know that metro systems have specific gauging problems because the track alignment must be kept extremely tight and precise in order to avoid infringement of the limits of a gauge that are very tight, as I repeat, in a metro line. In this case, metro lines are not particularly heavy in terms of axle load. They range from 12 to 16 tons per axle. That is much lower than conventional freight trains or heavy haul freight trains. Nevertheless, having the same type of vehicles running all of them at the same speed, that is something quite common if we think about automatic train operation systems, ATO systems. I have seen in my professional life some systems failing always in the same time, in the same way, in a very short time after track renewal, because all the trains give the same stresses and strains on the track. And this means that the track deteriorates much faster than you can imagine in a conventional network where you have a mixed freight traffic and mixed passenger traffic. So, as I said before, they are approaching the end of the technical life. For example, in Rome at the moment, someone is thinking about completely renewing Line A, that you can imagine as a backbone of a city transport in Rome, and replacing a ballast system with a slab track system that doesn't require future maintenance, as to me looks extremely attractive. In this case, closing a network line is impossible. You cannot even mention that in a meeting because you are fired suddenly. So you cannot even pronounce the word closing. Okay, you have to do it at night. So they work at night and run it along the day, and that's the general rule. And in this case, I see that the fast system, we have seen before a slide or a couple of slides with an additional mass installed on the system. We know that the cutting frequency of a vibrating system depends on the mass, of the natural frequency of the system. So the greater the mass, the lower the natural frequency. And this helps to reduce greatly vibration and re-radiated noise within buildings, so in nearby housing. And that can be really a very interesting feature given by the fast, which is heavier and has a better cutting, vibrational cutting behavior compared to ballast system. The last application that I see is on viaducts. Viaducts pass often close to buildings, to private properties, and this means that noise can be a relevant problem. I'm not talking about wheel rail noise that has a high frequency and that can be efficiently tackled by using noise barriers. I'm talking about low frequency noise and vibrations that come from the vibration of the structures. And this applies to both steel viaducts as well as to concrete. This photograph is taken from Google Maps, no secret. This is a stretch of the line in Naples, on the outskirts of the city, the line that is mainly underground and with a very nice, there is a helical tunnel underground. That's something that you should see. We know perfectly the helical track in Switzerland that goes on the mountains, but there is a fantastic helical tunnel in Naples. I invite you to join me in Naples. I often, as a consultant there since 20 years, so I know quite well that. And this is the part of a line that is outside the city, it's on the surroundings, and it runs on a concrete viaduct, and I can tell you that the noise is relevant, is important. And in this case, I think that the fast system, sorry, I didn't mention that, but I want to say that. To me, the fast system can be really something that helps to reduce noise and vibrations transmitted by the track to the civil engineering structure, increasing the mass and reducing the natural frequency. And my suggestion is to study the additional masses system in order to use them as a dynamic absorber. That's something that could give a further improvement in this system. And I wish Salchev and the fast system all the success in this world, and I thank you very much for your attention.